Yeah. All right, it's 1 o'clock. How are you all doing? All right? Let me get this thing turned off. It was brought to my attention that our main website, like Canvas website, did not have the link to the actual videos that I've been doing in class. So if you go to our main website now, I'll show it to you if I need to. Right in the front page, there's like right after syllabus or something, it says class lecture videos. You click on that and you can go find these videos, all right? So just so you know, you can go back and watch. It'll only capture what's on this board, but the video is actually pretty decent. It comes out pretty good. So, all right, any questions before I begin today? No questions? Sure? All right. Just bringing up our schedule real quick. Our first exam is September 13th, which is not next week, right? Not next Tuesday, but the following Tuesday. So we come back next week. There's a Monday. Monday is a holiday. If you have Monday, Wednesday classes, Monday's Labor Day holiday. So next Tuesday, a week from then, we'll have our first test. It'll cover everything up through probably 7.3. Today we are going to start 7.1. And the title to this section is Angles and Their Measure, I believe. Angles. I'm actually going to change this. Angles. And let's go with arc length. Linear speed. Angular speed. So the name of this section is actually just angles and their measure, but all of these are like the main topics of this section, the main ideas of the section. So if you're ever going back and reviewing your notes before a test and you're like, hey, when did we talk about, linear speed or something, you'll know it was today, all right? Okay, so let's get started. First thing, a lot of definitions today, a lot of, yes?
I have a question.
Yes.
So, are you going to give us a review for the exam?
I'm going to give you some sort of review, yes. Now, what I don't want you to expect is that I'm going to give you like a sample test and that when the test comes, I'm just going to change the numbers. I don't want you to expect that. You do need to get good at studying, right? So going back, reviewing your notes, reviewing your homework, learning how to study math is part of why you're here, because in calculus, it's the same way. You're not going to always get a review for something, but I will give you some sort of guide, all right? Especially for this first test, because you have no idea what to expect, right? Yeah, so I would expect next week, I'll give you something, probably on Thursday of next week, you get a review, and then we have the test the next time we meet. Good. Yes?
On MATLAB, is there a way to review past homework? Like if I want to go back and do stuff in the circle section?
I'm pretty sure you can go back and it'll say, you're going to go in here, but it will not change your grade.
Okay.
Has anyone tried that to go back? I'm pretty sure you can. Yeah, it's like similar question. But after it's already been turned in, I think you can just go back and review it.
Okay.
You should be able to. Yeah. Okay, any other questions? No? Okay, so let's get into this. There's a lot of objectives we have to get through today. So Let's see how you do with this. So we're going to start with the idea of angles, all right? I think for a lot of you this is going to be kind of like, okay, I've seen this, I'm somewhat comfortable with this, but there's little like small nuances we need to make sure we're clear with, because it could kind of come back to haunt us if we are unsure of something, all right? So the idea of an angle, let's start with this, angles, comes from a very simple idea, right? You start with a point, and then from that point you draw two rays. So when we talk about lines, a line is a geometric object that goes in both directions forever, right? A line segment is a line connecting 2 points, and then a ray is basically a line that only goes in one direction forever. So if I draw a ray like this, and then draw a second ray that's not the same ray, like this, then by drawing those two different rays, I create this object right here between these two rays, and we want to somehow measure this, right? And that's what we call an angle. Yeah, we know this, yes? This is our angle right here. Now when we represent angles, we usually use lowercase Greek letters to represent angles. Like normally when we're solving equations, we use x, right? That's the standard convention. When we talk about angles, we like to use Greek letters, lowercase. So the common angles that you'll see, let's call this theta. Okay, that's the Greek lowercase letter for t. And then the other ones that you might see, theta, that's theta. Anyone know what that is? Alpha, beta. What else does the book use? I think they use gamma. So this is not like a Greek letter class, right? We're not learning Greek language here, but there are certain things you do need to know. What are some other ones? Rho. So you can go look these up if you want, and there in the book they list what they are, all right? So if you ever see something like that, usually it means it's an angle, all right? Now, when we draw an angle, we have to, when we're trying to get some idea of how we're going to measure this, we usually label the two rays. In the first ray, it depends on you. You can label it however you want. Whichever one is going to be your first ray, you call that the initial side of the angle, and then this side is called the terminal side. And so you can imagine that to create this angle, you had to start from this ray and then rotate through some distance, and that distance is, again, the angle that we're measuring. And so this angle would go in that direction. That would be like a counterclockwise rotation, wouldn't it? Clockwise is this way, counterclockwise is this way. So that would be your angle, theta. Now, is there another way to get from the initial side to the terminal side without going counterclockwise? You could have gone clockwise, right? So you could have gone like this from here and rotated around like this and stopped here. So you still have the same initial side, you still have the same terminal side, but you've rotated a different way, haven't you? And so this angle is different than this angle. So we call this maybe alpha or beta or whatever you want to call it. But these two angles are different, aren't they? One of them is a counterclockwise rotation. The other one is a clockwise rotation. Okay? Any questions so far? Positive angles a positive angle is what you get when you do counterclockwise rotations. All right? So anytime you go counterclockwise, we will call that a positive angle. Anytime you go clockwise, it is going to be considered to be a negative angle. I think when I get to the next part, you'll understand why we chose counterclockwise to be positive and clockwise to be negative. We could have done it the other way. We could have all said, hey, let's call clockwise positive, but we did it this way. In a second, hopefully you'll see why that kind of makes sense. Questions? All right. So moving on from this. Sorry, if we're going to be drawing angles, right? If we're going to be drawing angles, then when I draw an angle, I can orient it anywhere I want. On a flat sheet of paper, I can put the angle anywhere, right? Anywhere. But oftentimes, most of the time, what we do is we want to orient our angle from we want to put that center where the two rays came from, we want to orient it at the origin, and then draw our two rays. And we say that an angle will be in standard position, okay? An angle is in standard position right? If it starts at the origin, and then the initial side extends through the x-axis in the positive direction. Okay, so what do I mean? If I draw an angle, right, I could draw an angle anywhere I want here. I could go, hey, look, here's two rays, and then I've got this angle theta here, right? I could do that. That angle would not be in standard position. An angle in standard position means I'm going to start at the origin, and then my initial side of my angle will always go down the positive x-axis. So this is always my initial side. And then from there, I either rotate positive or negative, depending on how I want to rotate, all right? But your initial side always goes down the x-axis in the positive direction. This side goes wherever. Let's just call this alpha. This angle, theta right here, this angle would be in standard position, okay? Nothing too crazy yet, right? Now, by putting an angle in standard position, if counterclockwise is positive, then if for any angle I draw, a positive angle is going to start here, and then as the angle gets bigger, it's going to go like this, right? And then rotate through like this, and then eventually come back around, yes? So when we look at it, it passes through these four regions of this xy plane, right? This first region, the first of the four, is called a quadrant, quad meaning four. And this would be quadrant 1. Quad 1. And then this one is quadrant 2, quadrant 3, and quadrant 4. It seems kind of strange that you would label something like 1, 2, 3, 4 until you realize that it's just because your angle, you want it to go through the quadrants in order, right? Through first quadrant, then into the second, then into the third, and then back through the fourth, right? So these are our four quadrants. So anytime we talk about an angle, we can ask, which quadrant is it in? Which quadrant? Unless the angle actually, the terminal side lands where? Like I can talk about, the angle's in the first quadrant, or second, or third, or fourth, unless the terminal side lands where? On one of the axes, right? So what do we call an angle when it lies on an axis, right? Does anyone know what you call it? No, that's the measure of the angle, saying what it's called. It's a weird word. So I'm going to just draw you a picture. So I'm going to draw you a couple of them. So let's say we have an angle that starts here, okay? And then that's our initial side, and then the terminal side is straight up. And I know you want to say that's 90 degrees. We haven't even talked about degrees yet. What I'm saying is this angle, right? Does this angle lie in the first quadrant? No, right? Is it in the second quadrant? No. Third? No. Fourth? No, right? It's on the y-axis. So this is weird. This is different, right? It's not in one of the quadrants. Same with this one. Here, rotate through and have it come straight across to here. Initial side, terminal side. Initial side, terminal side. See, again, this angle is not in one of the quadrants, right? Initial side, terminal side. There's my angle. There's my angle. There's my angle. And then, could we have this? Initial side, go all the way around, come back and stop there as well?
Yeah.
That would be an angle. That would actually be an angle. The initial and terminal sides are the same. It's kind of weird, but you go all the way around, come back. All of these cases here, these angles are called quadrantals. You'll probably never hear that word again, okay? I'm just telling you what it's called. A quadrantal. Yeah, I spelled that right. So other than quadrantals, other than these special cases, every other angle is going to fall into one of the four quadrants. Do you agree with that? No matter how you draw it, you're going to fall into one of the four. Okay, now let's talk about degrees. All right? Let's talk about degrees. So let's get rid of this. Now, most of you in here are very comfortable with this idea of degrees because that's normally what we see when we're kids. We talk about degrees, we grow up with it. But I want everyone to appreciate the fact that the idea of a degree is arbitrary. In other words, we could have done this however we wanted to as human beings when we decided to do this. We as human beings decided that if you ever have an angle in standard position that starts here, okay, and goes around all the way, right, and stops also where it starts and stops at the same place, a full revolution around, we could have chosen to cut that revolution up into any number of pieces. Just like when you think about a foot, we cut it into what, 12 inches? It could have been cut into 20 inches, couldn't it have? I mean, why do we use 12? Right? So it's arbitrary. We decided, right, we human beings decided that when you look at a full revolution around, we are going to call that 360 degrees. That's the measure of that angle. That's what we chose, right? So all the way around, this angle has a measure of 360, and then we have to put the degree symbol up here to let everyone know we're talking about degrees. The degree symbol is absolutely important, okay, vital, because there's another way to measure angles, and that's radians, and they're different. So you have to distinguish between the two. So this angle, let's call this angle theta. Theta, this would have a measurement, theta would have a measurement of 360 degrees. So with that in mind, can you see that you could cut this up then into, like, 1 degree would be 1/360th of a revolution. Right? So 1 degree, 2, 3, 4, 5, 6, 360 of these pieces. Think of it like a pizza, right? This is like a pizza that has 360 slices in it. 1 degree would be one of those slices, right? And you need all 360 to come all the way around. So what about this angle right here that goes from here to here? What would that angle be in degrees? 90. Now why? I mean, in terms of this, how can you, I mean, most people just know it's 90, but if we're acting like we just learning this for the first time, why would this straight up angle right here be 90? All I've given you is that all the way around is 360.
It's 360 divided by 4.
Yeah, it's 1/4 of the full rotation, right? So it takes 4 of these to get to 360, so if you divide it by 4, you get 90 degrees, right? And then this one here would be 180 because it's half of the full rotation. And then this one here would be 270. So it'd be, you could do it a couple of ways. You could do 90 3 times, right? 90, 90, 90. That would give you 270, right? Those are the common angles, some of the common angles that we need to know, right? Most of you, show of hands, and most of you know this, yes? These angles, common, you've seen them, not scaring you at all? This would be referred to as a quarter revolution, right? A quarter revolution. This would be a half revolution. This would be 3/4 of a revolution. This would be a full revolution. Oh, by the way, this is 360. I already wrote that. Oops, 360. Terrible. All right. We keep going. I know this is a lot of stuff you've seen, but let's do an example just to make sure you're good. I want us to draw some angles in standard position. So draw these. Sketch these. Sketch these angles in standard position. Let's go with negative 90 degrees. That's A. B, let's go with 135 degrees. Let's go with C. How about negative 225 degrees? And then D, let's go with 405 degrees. I want us to draw these. And when I say draw them, that means I want to kind of know like where they are, what quadrant they're in. I want a decent picture. So let's start with A. For A, start with our XY plane. I'm drawing standard position, negative 90. So I start with my initial side out the x-axis, and my terminal side will be where? Here's my initial side. Where's my terminal side? Straight down, right? Straight down. Why is it straight down? Well, we're going 90 degrees, which is 1/4 of a revolution, right? 1/4 of a revolution, but it's negative, which means we go clockwise. So I'm going to rotate clockwise to here and go straight down. And I'm going to label that angle negative 90 degrees. Whenever we have a perfect 90-degree angle like that, we usually put a little box in the corner, right? That's what we normally, y'all have seen that before? That lets everyone know, hey, you're looking at a right angle, 90 degrees. All right, how about B, 135? Well, hold on. That's not one we know, is it? So maybe it will help if we think about if straight up is 90, what would halfway be here? Half of 90, right? That would be 45 degrees. This is 90 degrees. And then here to here, if we went halfway here, what's that? So if this is 45, add another 45, you get 90, right? Add another 45, you get 135. So 135 is actually a pretty common angle that we're going to see quite a bit. 135 degrees. So let me draw the angle. That's just me kind of getting my reference. Here's my initial side. Here's my terminal side. And here's the angle. That's 135. C, part C, negative 225. So my rotation is going to be clockwise or counterclockwise here? Clockwise. Okay, 225. Is that a number we should know or no? Let me try this. Here's my initial side, right? Let's do the same thing we did on this one. I'm going to cut this into quarters like this. If I rotate backwards, negative, what would this angle be here? Negative 45 degrees. Okay, go another 45 this way, and this would be negative 90, wouldn't it? Then let's go again. Here? Negative 135. Here again? Negative 180. And then here to here? Negative 225. Wait a minute, isn't that this one? No. This angle and this angle are not the same, because this angle goes this way from here to here. Now, do they both have the same initial sides? Yes. Do they both have the same terminal sides? Yes. Right? They both start in the same place and end in the same place. The thing that makes them different is the way you're rotating to get there. All right? So they're not the same angles. This is negative 225. What we will call these in a little while, we're not quite ready for it. Does anyone know what we call these two angles? I mean, because they're not the same, right? This angle, I just told you, this angle and this angle are not the same because one of them is a positive rotation, the other one is negative. But they are related in the sense that they share the same initial side and same terminal. Does anyone know what we call them? When we have a standard angle and standard position that starts and stops at the same place? No? It's okay. We call these two angles coterminal. Does that definition make sense to you? Coterminal. Does it make sense? They both terminate in the same place, right? They share that terminal side. Now, of course, they both start in the same place because they're standard position, but any two angles that have the same terminal side are called coterminal angles. But that doesn't make them equal, it just means that they share the same terminal side. All right, so 2-point bonus on the first exam. First person raised their hand to tell me, give me an example of two other coterminal angles. Go ahead.
45.
45 and?
Negative 325? Maybe?
You're saying 45 and?
Kind of negative 315? I don't know.
Who else? I saw.
345 and 405.
Wait, 345 and. No, hold on. Go.
Negative 90 and 270.
There you go. Negative 90 and 270. Let me make it hard for yourself. Right? Negative 90 and 270. Let's draw those real quick. Negative 90 and 270. Here's negative 90, right? Going backwards, right? Or you could have gone all the way around like this, and that's 270. Remind me about the test. All right? Those are coterminal angles, right? They both start and stop at the same place. Any questions? 405, where's 405? Here's the way I would do 405 if I'm doing part D. I'd remind myself that 360 is all the way around, right? So if I take this and just subtract 360 degrees from it, what would be left? What is it? 45, right? So 45 degrees. So this is basically saying go all the way around, right? Counterclockwise. And then once you get all the way around, go an additional 45 degrees. So let me draw this. This one's actually pretty important that you understand this. Here's our initial side, right? This is our terminal side, right? That's our terminal side. But let's draw what the angle is. The angle is actually this. That's the angle. It's not just that little piece, it's the whole way around and back to this. Okay, this right here is the 405 degrees. So 405 and 45 degrees are both coterminal, aren't they? But 405 has a full rotation added on. All right, we got to keep going. Now, you know when you measure, when we measure something with like, let's say a ruler, right? You have like a 1 foot, and we said we could break that foot down into inches. And then each inch can be broken down even further, right? So the same thing works with degrees. We can take a full revolution and we can cut it up into 360 pieces, right? Which is what we've done. So that each degree, right? 1 degree, it's pretty small. I'm going to put it in here. This would be terrible. That is approximately 1 degree, all right, from my terrible picture. That's approximately what 1 degree looks like. It's 1/360th of a revolution, right? But sometimes we want to go further and get it more accurate than just a degree. We want to, refine it down, just like you can take an inch and cut it into pieces. So there's 2 ways we can cut this down. The first cut of this is to cut that degree into 60 pieces. Right? So we take 1 degree right here, and imagine coming in and cutting it into 60 equal pieces. So imagine 60 little smaller angles in there that are all equal. Each of those 60, each one of those, this is called 1 minute. And the way we write it is this, 1 with a little prime mark on it. So the relationship is this, that 1 degree is actually equal to 60 minutes. There are 60 minutes in 1 degree. So you could say that 1 minute is 1/60th of a degree, right? So another way you could write this would be that 1 minute is 1/60th of a degree. So those are equivalent. There's 60 minutes in 1 degree, or 1 minute is 1/60th, sorry, this should be 1/60th of a degree. That's the way I should write it. And then we can cut that down even further. So you see those minutes are really small, aren't they? Each minute is really small, but imagine taking one of those minutes and cutting it into 60 pieces. We can do that, and we do. And that's called, anyone know what that's called? The seconds. Okay, so we kind of have to imagine that we're going to zoom in on one of these, right? And now we've got right there, okay, that right there is 1 minute, okay? That's 1 minute right there. We're zooming in on one of those. And now I'm cutting this into 60 equal pieces, and each one of those is called 1 second. And the way we denote that is 1 with double prime on the side.